Even
from the logo, that is the logo we have, which is this one. I'm doing the math part.
No, but okay. No,
That is the
which
filter
file
part.
are you doing? The one I sent you in the group,
Yeah,
or
yeah.
or we are doing the part two file,
The one you sent to us.
the new one, right?
Yeah.
Okay.
There is in footer. You
Don't
can see
forget
my
the
name.
basic thing. Did we change the database? We change it today.
Yeah.
Like that's the most important thing of it. This edit thing, will you take care of the number. I'll take care of the footer and all.
Yeah,
Like copy it and all.
do like the homepage things like here.
Okay, perfect.
Yeah.
Perfect.
And then the header.
Like we are almost done, right? We're not that behind. We're not that behind. We're almost there, right?
Yeah, I think we just need to change something.
Yeah.
Like
That's our rule. Everyone today to just have a meeting because everyone will divide work because some of the guys will not be able to get it. So it's better that if we can divide the work and get it done by tomorrow or by Saturday, right?
yeah, what I have done, I think I've done like footer, the day,
Perfect.
and the homepage. That's it. But it's weird that I cannot when I try to open it, it's not working. I don't know
Why?
how to say.
Normal? Normal is what?
No, no, it's like I don't know if it's not out. The old thing, but I have changed the new one, but
No, it's not showing. Did you save it?
yeah, I think it's opposite.
Okay.
But I don't know why.
I'll figure it after.
Yeah.
Okay.
See you.
Okay. No worries.
afternoon, everyone. Let's start with the contents of this week. So we are going to discuss about multi-threading or concurrent programming. So you guys have heard about what is thread or what is multi-threading? Do you have any idea what is multi-threading? No idea? Vinshan, any idea? No? Okay.
Is it like multiple things?
assignments are due this week. So many of you maybe, with the lecture you're trying to do the assignments. So that is again an example of multi-threading. You're trying to do multiple tasks at the same time, right? So if suppose I tell you that you have 3 courses, suppose there is Comp100, there is Comp228, and there is Comp123, suppose, okay? So there are 3 programming courses, and I give you the textbooks of all 3 courses on your table. And I tell you that you have to read all these 3 books together. What do you think? Will it be easier or will it be difficult?
Harder.
Why do you think it will be harder? Difficult?
To do all of them at the same time.
All of them at the same time? Why? What are the constraints, or what do you think will be difficult in that?
The resources, the focus.
Yeah, focus is the important thing. What else?
Not getting confused.
Getting confused, maybe which book you were reading, what page, where exactly you were pointing to, and then again, despite of that, you were, you might get confused between the syntaxes of C# and Java because they are all together, right? So this is the problem. Like, this is a simple example of concurrency or programming based on multi-threading. So think about doing it in real programming terms. First only you're doing programming, and then you're trying to do it concurrently. So how difficult it would be to maintain the state of that particular process and then get back to that state of the process, right? So obviously, multi-threading is not a simple topic. It's a very vast and a difficult topic to be actually implemented in programming. So Java has some APIs that are tried and tested. So we don't have to worry that how it's gonna do it or what exactly it's gonna do it. We are just gonna use that. Okay? So let's talk about multi-threading today. I'm not gonna review the last session. So we're gonna talk about thread and life cycle of thread. We're gonna talk about thread priorities, thread scheduling. We are gonna create and execute threads. We are going to talk about runnable interface. This is synchronization, multi-threading, fork, join framework. So this is just very wide and huge. So the more you learn, there is something more to be learned. Okay? So I'm just going to give you a brief introduction. Going into depth, how much you want to go into depth is up to you. Okay? So we are going to talk about concurrent execution. So we have, we know that computer can do it very well. It can execute all the instructions concurrently. It can switch easily from one task to another, unlike human brains, right? So if there are 6 number of processors or 6 cores in your processor, why not utilize them properly rather than just giving one task at the same time as a programmer, right? So the best example of this might be if you're trying to play a video, okay? So you might think about it as downloading the video and playing the video, okay? If you're a normal programmer, you might go with writing a code for downloading the video and then writing a code for playing that video, right? So a normal user who's trying to use your program will have to wait till the time the download is performed, and only then the video will be played, correct? But if we are using multi-threading, so concurrently both the tasks are done, that is downloading as well as playing, right? So isn't it wiser to use concurrent programming then? Do you want to wait for the video to be downloaded in order to be played? Or you want both of them to be done concurrently? When it is downloading, you should be able to play it. Concurrently is a better option, right? So the concurrency can be achieved in computer programming. One of the ways is using threads, okay? So multi-threading can also increase the performance on single processor systems that simulate concurrency when one thread cannot proceed because, for example, it is waiting for the result of an IO, or another processor can use the time. So let's think about this as like this, okay? So your one thread is trying to download the data and second thread is trying to play that downloaded data, right? But the play thread cannot play unless the data is available and downloaded, right? So the preference should be given to downloading as compared to playing. But you're gonna play as well. But once the downloading is done, then you should try to play, correct? So these kind of, some issues that one of the thread is waiting, so in that case the second thread can go on, right? So when the playing thread is waiting because downloading is not done, so it's gonna give the processor time to the second thread which is downloading, and it's gonna start downloading the data. Okay? So this is about, so we already spoke about this application, that is playback of an audio or video clip while it is downloading. Another example is synchronizing the threads so that the player thread doesn't begin until there is sufficient amount of clip to play the thread, to keep the player thread busy. So synchronizing is a very important aspect that comes into picture whenever you are talking about concurrency. So if two threads are working at the same time, one is downloading, another is playing, so player should not start unless the data is downloaded, right? So before playing, it is gonna make sure that data is downloaded, right? So this is the main issue that comes into concurrent programming, and we'll look at this issue in the details in today's session. So JVM creates threads to run a program. JVM also may create threads for performing housekeeping tasks such as garbage collection. Okay? So in the background, whatever you are creating, suppose you are creating a database connection and you forgot to close it. So now there are some, compiler is smart enough, it can point to that you have not closed particular thing. But previously, if you open something and you don't close it, it's the responsibility of garbage collection. And there is a thread in the background which is responsible for doing this duty of garbage collection. Then programming concurrent applications, as we have discussed, is difficult and error prone. Now let's talk about threads life cycle, how threads actually work. Okay? So threads occupy one of the several thread states. So there are some states that thread can be in. So it is going to be in one of the states that it is allowed to be in. Okay? When the program starts the thread, it enters the runnable state. Once it starts, it is in runnable state. Consider to be executing its task. So when it goes into runnable state, it starts working or executing its task. Runnable thread transitions to waiting state while it waits for another thread to perform a task. And it transitions back to runnable state when another thread notifies the waiting thread to continue. So we'll look at the diagram which will explain us better. So when the program creates a thread, the thread is into new state. Okay? First state is new. When the thread is actually a new thread, it's just created. Then when the program starts the thread, it goes into runnable state. Okay? And when it is in runnable state, you can execute. Runnable thread is something that can be executed by the processor. Okay? Now when you say wait, instruction, or when you give wait instruction to this thread, it's going to go into wait state. And it can come back to runnable state only if someone specifies notify or notify all. So there will be some functions we'll be talking about, notify or notify all or wait. So this functions, it's just showing here. So when the thread is given the wait function, wait function is called on the thread, it's going to go in waiting state, and once it is notified, then it goes back to runnable state. Okay? Now, sometimes it might happen that wait is for particular time. For example, you are saying that wait for 10 milliseconds or wait for 20 milliseconds. So this is a particular time you are saying that program should wait or the thread should wait. So this is called timed waiting. So in this case, the thread goes into timed waiting state. And when this waiting state is finished, it goes back to runnable state. Okay? So when that interval is going to elapse, at that time it goes back to runnable state. And if suppose this thread is running and its task is done, for example, downloading is finished, so the thread terminates. Okay? And lastly, the thread is running, but it is waiting for user input. So it issues a input request for the user and it goes into block state, meaning that it cannot run. It is waiting for input or output. So it goes into block state. And once it gets the user inputs, only then it will be able to become runnable, or it's gonna be runnable. Okay? And here in runnable, if thread is runnable and it is going into a block statement which is synchronized, and it entered a synchronized statement, so it goes into block state. And it can only go from block to runnable when it is able to acquire the lock or when it is able to interrupt. So we'll look at what exactly is lock, what exactly is synchronized statement. Okay, hold on here. We'll talk about synchronized statement in a moment, and then I'll come back to this life cycle. So these are the states, life cycle. Okay, once the thread is runnable, that means the processor can run that thread, right? So once the processor can run that thread, it can go into two states, ready or running. Okay, ready is when the thread is ready to run, but it is not yet started running. Okay, ready means it is ready, you can give it to the processor anytime, but it needs processor times, right? If it is ready, it can be given to the processor and it goes into running state. And when the quantum expires, that time it goes into ready state again. So, best example, there is a thread T1, there is a thread T2. Both the threads are runnable state. They are both ready to be run. Okay. Now, there is this processor which has its time, right? Processor has its fixed time. So, processor, suppose considering that our machine just has one processor and there is just one time on that processor, right? So, at the same time, it can run just one thread. It cannot run both the threads at the same time. Okay? And we want to run both the threads. So what it's going to do is it's going to use the concept called time slicing. I think you might have learned about it in other courses like operating system or system design, right? So in this, you're going to use a time slice, and that time slice will be allocated to thread. So T1 will be executed for maybe 5 milliseconds. After 5 milliseconds, the other 5 milliseconds will be given to T2. Again 5 milliseconds will be given back to T1 and then T2 and so on. This is going to continue till either of them completes its execution or both of them completes their execution. Correct? So, this is how concurrency or concurrent applications or threads are running in the background. something called time slicing is used, wherein once the thread is ready, it is gonna go into running state, and when its time slice or quantum time expires, it's gonna go back to ready state. Okay, when T1 is running, so it's in running state, but T2 is in ready state. That is, it can run, but it is still ready to be running. Okay? Any questions so far? Any doubts? Anything you want me to repeat? Everything's clear? Now, the only problem with thread is that it can lead to some unusual states. Okay. Now let's talk about first thread priorities and thread scheduling. Okay, so as everything needs to have priority, for example, if the thread is related to system programming, or if it's a operating system based process, so it has higher priority as compared to application process, right? So that the system should work fine. Everybody knows that basic in our computer, in our systems. The system-based processes have higher priority as compared to the application processes, right? So likewise, threads also can have priority. You can have a minimum priority thread, you can have a normal priority thread, or you can have a maximum priority thread. So if suppose there is, a hospital system, you want to give a higher priority to someone who's senior, you're gonna give that thread a maximum priority, right? If you want to give a normal priority to a certain job, you will give it normal priority. If you give a maximum priority, that means you're giving it an integer value of 10. If you're giving minimum, you're giving an integer value of 1. Normal priority, you're giving them an integer value of 5. Right? Each new thread inherits the priority of the thread that created it. Okay? So if you say that thread 1 is created under thread 4, so whatever is the priority of thread 4 is going to be inherited by thread 1, right? So this one I told you that if assuming that thread 1 and thread 2 have same priority and they need to be executed at the same time, so they are going to use something called time slicing, right? So this is what time slicing enables thread of equal priority to share the processor. And informally, higher priority threads are more important and should be allocated processor time before lower priority threads. This does not guarantee the order in which threads execute. And finally, thread scheduler decides which thread to run. It is the job of thread scheduler to decide which thread needs to be executed first based on its priority, based on the resources that it needs, and based on time slicing it's doing. Higher priority threads generally preempt the currently running threads of lower priority, known as preemptive scheduling. Now, this is very important. Suppose a patient who's senior is waiting in the queue, and there is a pediatric patient who's got a fall. So he's bleeding. So his priority is more than the senior who's waiting, right? So once the pediatric patient is gonna come, the senior will be waiting. He will not be given priority. If someone is there with the medical representative, they will move out, and the pediatric patient who needs immediate care and immediate attention will be given that spot. So this is called preemptive scheduling, wherein a higher priority thread is given more importance and given the processor time before the lower order priority threads. Okay? Now, this can lead to a problem which is called indefinite postponement or starvation. suppose there is a thread T1 with priority 5. There is thread T2 which came with priority 10. Which thread will be executed? T2 will be executed. Now T3 came in. His priority is 8. Which thread will be executed? T3, right? Now T4 came in. His priority is 7. Which thread will be executed? T4. Now T5 came in. His priority is 6. T5 will be executed. Now everyone got the CPU time except for T1, who's still hungry, still did not get any food, right? But others, they had higher priorities, so they got the CPU time, right? So he's still starving. So the concept is called starvation, because someone who's at lower priority, they're never getting the CPU time. So there are some systems wherein, you know, if someone is starving, someone is hungry, make his priority higher. So his priority becomes 6 after starving for like 5 milliseconds or 10 milliseconds. Once it exceeds, its priority is gonna increase. So that it does not have to be hungry. It doesn't have to stay hungry, right? So this is about some priority schedulers. So this is a very good example to explain the thread priority scheduling. Okay? Suppose there are threads A, B, and the priority of these threads are 10. There is thread C, whose priority is 9. So how will they be executed? How about A, B? If both are at same priority, how will they be executed? Excellent. They will be executed using time slicing. So they will go into which states? Ready and running. Awesome. So they will go into ready and running states. So first A and B, both will be executed concurrently using time slicing. And then the next priority of the process C is 9. So once they complete the execution, both of them, only then C will be executed, right? And then there is this 8 priority, there is no thread. Then 7 priority, there are 3 threads. So we'll perform time slicing for these 3 threads. Then G, so alphabetically it's gonna be executed because the priorities are alphabetically, right? So actually A will be executed, then B, A and B, then C, then D, E, F, then G, then H, I, then J, and then K. Okay, so this is how they will be executed. Now this is very important. The only drawback of thread-based programs is that you won't be able to predict the output. Why? Because the output of this thread-based programming is platform dependent. So what platform you are using, what hardware, what software, what's the operating system you're using, everything is going to make difference on the execution of your program. Okay, so the output which I am going to get on my system is not the one that you're going to get on your system. Okay, so sometimes it's going to work differently on different systems, and how it's working or which thread is executed first is not fixed. For this one, previous program, it might happen that for my system, A thread is executing first, but for your system, B thread executed first. So the sequence in which these threads are executed may not be same for all the systems. So the behavior could vary across different Java implementation. So when designing multi-threaded programs, consider the threading capabilities of all platforms on which the programs will execute. Using priorities other than default will make your program's behavior platform specific. Okay, so if you're giving any other priority like 9, 10, so it might become platform specific, but if you keep it default, it's gonna be better, so you shouldn't, adjust the priorities if you are trying to make your program platform independent. Okay. So how do we create and execute threads? So first thing, your class can extend thread class. Extends thread class. That is one way. And second way is your class can implement the interface, which is implements runnable interface. So these are the two ways using which the thread-based programs can be created. So this is the task class that you will create. So either the task class should implement the runnable interface or extend the thread class. Now when to use implements runnable and when to use extends thread? When should I use this one and when should I use this one? Yes.
So runnable is when other tasks also do
Sorry?
other tasks.
When other tasks?
Yeah.
Sorry? Can you repeat the word?
When other tasks concurrently
When other tasks concurrently
execute is connected to something.
is connected to something. What do you mean by connected to something? You're very close.
Executing something from another thread.
Execute what from another?
Another
Interface. Okay. Very close. Anything else you guys want to guess? So what's the drawback of our Java program? We cannot do multiple inheritance, right? So if I want to extend one more class here, so for example, I want to create a GUI, so extends application, or I want to create, okay, I want to create a JFrame, so extends JFrame. So can I do this? Extends thread as well as extends JFrame all together? No, right? So I have to use implements runnable whenever I have one more class to extend. Correct? So I'll use implements runnable in that case. Okay? Good so far? Any questions? Any doubts? Okay. So once you implement the runnable interface, you say implements runnable interface, then what you need to do? You need to define and implement the method run. Okay, so run method need to be defined and implemented for runnable interface, right? And what is the run method? It's gonna say what exactly the thread needs to do. So when you start the thread, what actually it's doing? It's executing the run method. Okay? So there is again a method called sleep, which throws interrupted exception if sleeping threads interrupt method is called. Okay, so this sleep method is again available inside this interface, and when the thread is sleeping, that time also there can be an exception, which is called interrupted exception. Interrupted exception. Okay. When the sleeping threads interrupt method is called, so in that case, it's gonna throw interrupted exception. And the main method code is gonna execute the thread which is created by JVM. So JVM actually creates a thread for executing the main method. Okay? So this is an example program. There is print task, which is implementing runnable. So there are some, final values, final fields for the print task. There is a constructor. There is a random number which is generated for sleeping for the thread. So the thread should sleep for a random number of amount of time. So we just created a random generator. Now when it implements the runnable interface, so we have to make sure that run method is defined, and run method is going to define what exactly the thread needs to do. So here we are specifying that the thread should do these tasks. And what exactly it is doing? It's saying task name going to sleep for so many, which is sleep time, milliseconds. So it's just printing that this task is going to sleep for this milliseconds. And the task is actually sleeping, calling the sleep from thread class for that sleep time. So the thread class has a sleep method, ready sleep method, which is gonna make the thread sleep. Okay, so this is a good way to make someone sleep, right? Then there is a catch exception. It's gonna catch the interrupted exception, and it's gonna print that it's interrupted because of some reason, whatever reason it is. You want to print that reason, you can print the exception.message. And then you are printing done sleeping and the task name. Okay? And this is how you're gonna call or execute the thread creator class. Okay? So you are creating, so let's see the example program.
It's for processing cores, right? For CPU multiplying to put the different cores.
Sorry, I didn't get you.
It's a multiplying for CPU to put in a different cores.
We are not going to the core level, but if you want to go to the core level and you want each and every processor to be used, each and every core needs to be used.
Bring it in, multiplying like in C#, basically creating like the threads, we put the threads to the layers, that's what we want to execute. And the syntax is what the syntax is like for the processor to keep up.
Yeah, so you can do it at the ground level, but Java provides API that we are using, so we don't have to go at the core level. Okay, we are just using the existing methods or existing classes to execute this multi-thread based programming.
Basically, it's again just one core for the process, right?
One core loaded. Yeah, that is correct. So it's the job of thread scheduler, thread executor, executor framework to decide as to which processor needs to be used. Okay? So this is the example program. So first thing is your class is implementing the runnable interface, okay? And you are saying that there is a generator which is secure random generator. There is a sleep time which you are specifying, which is a random time for which the thread is going to sleep, and there is a task name which is just specifying this is the task, right? It is used to recognize what task is executed. And in the constructor, you are writing the name of the task inside the task name, and you are saying that sleep time, which is generated by the generator.next in, and it's going to be between 0 and 5 seconds, which is 5,000 milliseconds, right? And in the run, so this is the main method. If you are not writing this method, if you're implementing runnable interface and suppose there is no run method in your program, so it's gonna give an exception. So this is the error. It's saying that the print task must implement the inherited abstract method runnable.run. So we have to write this run method if you are implementing runnable interface, because that's the place where you specify what the thread needs to do, right? So we'll write the code for run, and the code here is doing nothing, just it's printing that this task is going to sleep for this amount of time, and it's putting the thread for sleep, for that sleep interval, and it's printing the exception, and thread.current thread.interrupt, so re-interrupting the thread, and printing the task's name and saying that task done sleeping. Okay, but this task or this thread is not yet created. So there are a number of ways using which you can create the threads. So for example, in the PowerPoint, you can see the threads were created: thread 1, thread 2, thread 3, and thread 1.start, thread 2.start, and thread 3.start. So this was the syntax that was used back days, right? When thread programming was not so advanced. But this has a lot of disadvantages that, how or the way the threads are managed is very difficult, right? It's not done correctly, or it's not gonna give a good performance, and performance is our objective. So there is a thread management which can be done with executor framework. So executor is defined as actually there is a framework or API that is provided by Java, using which the thread pools or threads are managed properly. Okay, so executor object creates and manages a thread pool to execute runnables. Okay, the job of executor object is to manage a thread pool. Okay, so if there are 5 number of threads, they will be placed into the pool, and once one of the slot in the pool is completed or is empty, the new thread will be placed at that location. Okay, and how they needs to be managed, how they need to be executed will be decided by the scheduler, right? So there is the advantage that it's gonna reuse, the executor is gonna reuse the existing threads to eliminate the new thread overhead. So every time we are creating a new thread and then thread name, right? But this, using the thread pool, you don't have to create a new thread every time. It's gonna reuse the existing thread. It's gonna improve the performance by optimizing the number of threads to ensure that processor stays busy. Okay, so it's not that thread pool is gonna have hundreds of threads. It's gonna have optimum number of threads so that it's gonna keep the processor busy and complete the task as well. Executor method execute accepts a runnable as an argument, assigns each runnable it receives to one of the available threads in the thread pool. If none is available, it creates a new thread or waits for a thread to become available. Now, here we are creating this task executor. So we are using this executor service, which is from this interface, which is available inside java.util.concurrent.executor service. So executor service is actually an interface. It is returning this executors.new cache pool is returning an executor that provides methods to manage termination and methods that can produce a future for tracking progress of one or more asynchronous tasks. And it can be shut down, executor service can be shut down, which will cause it to reject new tasks. 2 different methods are provided for shutting down an executor service. First is shutdown. Now shutdown, what it does is it will allow the tasks that were submitted before shutting down to be executed, and shutdown now method, which prevents the waiting tasks from starting and attempting to stop currently executing tasks. So if you want, if you have these 3 tasks and you have provided them to execute, and then you are saying shut down, and if these tasks were not executed, they were not completed, still in the background it's gonna let the execution of task go on. But if I say shut down now, it's gonna stop executing this task. So let's see, we are trying to print task, we are calling this print task 3 times. So we are executing this print task 3 threads, right? And giving all 3 to the executor service. So what exactly is happening? First, it started executor. So starting executor, this is printed. Then task 1 going to sleep for 3705 milliseconds. So it went here, it called the run. So it said this task name, which is task 1, which we provided here, which was this task. Okay, task 1 is going to sleep for how many milliseconds? So there is some sleep time which is generated by random number. So it generated the random number as 3705. So it went to sleep for these many milliseconds. And same is happening with task 2. So we said task 2 also execute and task 3 also execute. So it went to task 3 now. It did not execute task 2. But you might see that on your system, it is possible that it's going to change the sequence in which it's executing, right? Because this is thread-based programming, so it's dependent on the system, right? So task 2 is going to sleep for 900 milliseconds. And since task 1 is already sleeping, task 2 is also sleeping. Sorry, task 3 is also sleeping. So it went to executor.shutdown and it printed this. Task started, main ends. So it's printing, it completed the execution of the program. But since it's shut down, so it's in the background running those tasks or running those threads. Okay, so you can see that it runs now the thread 2, which is task 2. It's going to sleep for 32 milliseconds. And once it prints that, then what it is doing is it's just printing once this is sleep time is done, it's just printing that this task is done sleeping. So once the task 2 had like minimum like 32 milliseconds, so it's gonna say task 2 done sleeping. Then task 3 had 900 milliseconds, so it is done sleeping then. Then task 1 is done sleeping. Okay? So you can see all of them are concurrently running. Which one is running when? We cannot decide that. It's gonna be processor dependent. But once the task is ready, it's gonna be executed in the CPU time. Okay? Any questions? Any doubts? So this is the framework, which is executor service framework. So executor framework, which is an API that is provided by Java, which we are using to get our threads executed. Okay? Can you change the timeout? This sleep time you're talking about, right? Yeah, we can. So second time if I run, it's gonna pick another random numbers. So you can see the interval is this, and this. So task 2 done sleeping, then task 3 done sleeping, and then task 1 done sleeping.
Yeah, so you can provide custom sleep time for each thread.
Sorry?
You can provide custom sleep time for each thread.
Yeah, we can provide the thread sleep time as well. Okay?
What is the reason the task 2 is usually
Sorry, I didn't get
In
you.
task 2 is running as a third.
Yeah, it's completely up to the processor. It
But
decides
the
as
first
to.
one was like this, the second one is like this. First task 1, task 3, and then task 2.
You can run on your system and check if the sequence is the same. Always it's happening that way only for my system. But you can try on your system. Is it happening the same way? But it's not that, it's task 2 that's why it's executed at the third place. No, there's nothing like that. It's completely up to the system. Whichever thread is ready, it's going to take that to running state. Okay? If the priority is same, it's doing the time slicing then. If someone goes to sleep, it's taking the another thread at that time. Okay?
Set the priority.
Yeah, you can set the priority using just setting the priority for the thread is, you can set here. So thread. Give me a moment. I will show you the method that is there for setting the priority. There is a set priority method which is defined inside the thread class, which can be used to set the priority. So, is it a static method? Let me just check. It's a final method. This one is 10. Okay, so I'll make the task 2's priority as 10. Look, I have set the priority for task 2 as 10, but still task 2 is executed at the end. So let's get the priority for task 1 and 3 so that we know what is the priority. Task 1 dot get priority. priority for task 1 is by default, which is 5, and we have set the priority for task 2 as 10, but still you can see that even the priority is 10, it's executed at the end. So even though you are setting the priority, that does not guarantee that it's going to be executed first, because it is completely platform dependent, right? So priority setting is not making a difference here, because what we are doing here is, we are using the executor service to perform these tasks, and if I want to set the priority, I have to extend the thread class. Only then I will be able to set the priority, because setting the priority is only available inside the thread class. So if you go to thread class,
I didn't understand that.
so if you go to the thread class, it has the method which is set priority. So there is a priority associated with the thread. But when you talk about runnable, there is a get minimum priority, maximum, normal priority. There is a maximum priority that we were talking about. But when you talk about runnable, the same thing, I am implementing runnable interface here. So in this case, get priority is not available, set priority is not available, right? So you cannot do that in runnable interface, because runnable interface is just an interface. It does not have definition for any other methods like set priority or get priority, right? So it is up to the task executor. It's gonna set the priority depending on the number of constraints that it's gonna take into consideration. And executor service is, an independent framework which is responsible for everything. It's gonna decide which thread is gonna be executing, which thread needs to be executed first. Because we are using executor service, that's the reason the set priority is not working for us, even though I use the thread. So if I want to use just extends thread, and then I can set the priority, then I can use the just thread.start, okay? Then that's gonna work. But otherwise, the executor service is not gonna take into consideration the priority of the thread, okay? So I'll just show this demonstration. So if I set the priority, I need to extend the thread class here. And here I need to start the task. Let's run this and see if it's running. So we started the executor, then we set the priority for task 2 as 10, then we set start task 1.start, task 2.start, and task 3.start. So task 1 started, task 3 also started, and task 2 started after, even though the priority was set to 10. And then the task sleeping was done, and before that only we started this. ways it's not taking into
Otherwise,
consideration. Sorry?
do the same thing.
Still the same thing. Yeah, so we don't know how it's gonna execute it, irrespective of the priority that is set. Usually, it is the priority that is gonna decide as to, you know, which task will be executed. But obviously, it's system dependent. So here, even though the priority is set as 10, so maybe we'll say task 1 dot set priority. It's modifying anything. No, still it's doing the same thing. So once it's ending the main, only then task 2 is starting its execution. Is there something different in task 2? I don't think anything is different. So it's completely, you know, you cannot predict which thread is executed first. But the background, it's gonna try to execute all the 3 threads, and the highest priority will be given to higher priority thread. Okay? So,
Professor, in real world coding, in which situation are you use this?
sorry, which?
In real world coding, I mean, in the real, so because it's, I don't know in which situation we can use this.
Priority based, you're talking about priority?
Yeah.
So if you want the thread, you know, downloading to be done, only then playing should be done for the video, right? So you can give a higher priority to downloading in that case, okay? Or if you want, you know, certain task that is very important, and you're gonna take the output of that task to another task. So you have to set the priority of that previous task higher than the second one. But usually this is what we had to do in previous programming. Now because of the frameworks, I think the priority has been removed. Let me just go through the documentation why this priority is not working. Let me see.
It could be many pools.
Many tools. Yeah, maybe that is correct. That is possible. Yeah, whatever Igor is saying, maybe that's the case. So maybe there are many pools. So at the same time, it's trying to execute the thread of all 4 threads concurrently. So the first line of the thread 1, 2, 1, 3, and main and task 2, all of them are executed at the same time, like using the time slicing technique. Okay, so that's the reason we are not able to visualize that, but usually it's the case that, you know, if the number of thread pools are just 1, then you'll be able to visualize this priority based pool. That's a good point, Igor. Yeah, probably that's the reason because of which it's executing all of them together. That's the reason we are not able to visualize it. Okay, so any other questions, guys? Anything you want to try? Okay, one more thing we can try is, you know, this one. Okay, and then there is this. Implements runnable. Okay, now here, if I use the method which is shut down now, what's gonna happen? The documentation says that this method is gonna attempt to stop all actively executing tasks, halts the processing of waiting tasks, and returns list of tasks that were awaiting execution. So let's see tried starting executor, task started, main ends. So task 3 going to sleep for so many milliseconds, task 1 going to sleep. Now it's trying to shut down all the executing thread. So it's trying to interrupt the thread to say that, you cannot execute. So sleep interrupted, and task 2 going to sleep for so many milliseconds. Task 3 done sleeping. Again there was another thread who was interrupted, saying that you have to finish execution or you have to stop the execution. So it's again interrupted, and task 2 done sleeping. So you are trying to shut down the service that are executed and that are in sleep mode. So these 3 tasks are in sleep mode. That's why it's saying sleep interrupted. Still it's executing those tasks even though it's interrupting the tasks, but it's still running it. Whereas if you say just shut down, it's just going to allow everything to be executed in the background, right? Yeah, so this is about simple thread-based programming. Now here the only drawback is that which thread will be executed when, you cannot predict, right? So suppose if my program has an array, okay, this is an array in my program, and the contents of the array are 1, 2, 3. Suppose this is an array, okay? Now my thread T1 is trying to write 6, okay, and my thread T2 is trying to write a 4. What do you think? What will be the final value of the array? 4. Why do you think it will be 4? Even though we give priority, still it executed some other task, right? One memory slot for 4.
If they're both in 2, right?
They are both
In 2, in second.
in second. That's one, index 1, right?
No, I mean T1 and T2 in 7. Right?
Both of them are writing at this place, which is
No,
index
6 or 10.
6 or 6 or
No,
Yes.
when they combine add to each other, T1
okay, someone saying combine, or someone saying we don't know, 6, someone saying 4, someone saying 10. What is
Would it be 4 because T2 runs last?
not exactly, because if you try to run the same program on your system, it might not be that T2 is running last. It's only my system that doesn't like type T2. On my system it was running like T1 and then T2 and then T3. Everything was running good, but on Colin's system T2 is running at the last.
What's going to run last? That's why.
Okay, so whichever is gonna be executing last, that will be the value. So if your system is executing T1 first and then T2, so the value will be 4. If it's executing T2 and then T1, the value will be 6, right? But we don't know when which data will be executed, correct? Do we know which thread will be executed? Right now we were so confused, right? Why is it executing first T1 or T2 or whatever it is, right? So we cannot determine when exactly that particular thread will be executed. That's the only drawback of thread-based programming, right? So we saw this executor framework. Okay, we saw this method which was new catch thread pool. What does this do? Is it's gonna reserve a thread pool that is a fixed number of slots for the threads. As Igor mentioned that the thread pool maybe is bigger. So it's trying to run all 4 threads at the same time. And that is correct because there is this executor that is going to create a thread pool. If the thread pool size is 5, so it's going to run all 5 threads together. If thread pool is just 1, it's going to execute the 1 thread at the same time. Okay? So if you have 5 tasks, one of the tasks is at higher priority, but the cached pool has 5 number of slots. So it's trying to execute all 5 of the tasks, irrespective of their priority, because it can. It can execute 5 tasks, right? So that's what happens with executor service. So you can decide how you want to execute the thread pools. There are a number of methods available inside the executors. So if you go to your program and you go here, so you can go with executors dot, and you'll see all the methods. So there is a new cache pool that we used, new fixed thread pool. So you can decide how many number of pools or how many number of threads are there in the pool. So you can decide you want only 2 number of threads in the pool or just 1 number of thread in the pool. So I think you can try priority based and you can try fixed thread pool and just 1 thread pool, 1 thread in the thread pool and see how it's working. Okay, so you can specify how many threads, and you can also use new scheduled thread pool, which is actually creates a thread pool that can schedule commands to run after a given delay or to execute periodically. You can also say that after a particular period, you should perform this or you should go to sleep or whatever you want to do. And if you want a single thread executor, so you can do that as well. So this is a single worker thread operating off an unbounded queue. If a single thread terminates due to a failure during execution, prior to a shutdown, a new one will take its place if needed to execute subsequent tasks. Now, if you want to go into details, you can go into details and see what all are the methods that are available inside the executors. Okay, but the most used one is this one. But if you have a bigger task, heavier task, you shouldn't use this because this is too heavy to perform bigger tasks. If some of the tasks are bigger one, so it's gonna affect other threads as well. So you shouldn't use this whenever your tasks are bigger. So this is about executor. Then execute is gonna return immediately from each invocation, and shutdown notifies to stop accepting new tasks, but it's gonna continue executing current or existing tasks. So this one we have seen. Now very important example is multiple clock example. So this is the best example of thread-based programming. So you want concurrently the 2 clocks to be updated. So let me show this example. This is a very interesting example. So this is multiple clocks. So if I run this program, so this is my output of the program. What exactly is happening here? So you can see the time is displayed for American Standard Time and European Standard Time, European or Paris time. Okay, and it's trying to update both the clocks simultaneously or concurrently, because it should not happen that American time is correct but the European time is not correct, right? So let me there is some problem here. Zooming.
It's doing the same thing for me.
What is it doing?
It's just like it's not showing all the values, right?
All the values? Yeah, but It's going out of the screen. It's going, out of the screen here.
Oh no, it's just saying the letters. Like if you drag it, yeah.
Yeah, but it's okay. We'll see that afterwards. So the time should be updated in both the clocks. So here you can see it is concurrently updating both the clocks. So each and every second it's updating both the clocks. Correct? So how is it doing that? So if I say one task, I'll give update the clock. Second task, update the second clock. So may be possible that the processor is busy updating one clock and it's not able to update the second clock simultaneously, right? So in this case, you have to use thread-based programming for updating all of the clocks at the same time. So what it's doing exactly in the program, so our clocks extends the J panel and implements the runnable. J panel is for just displaying the J panel. On J frame you'll be adding this J panel, so we are just displaying the GUI. And then there is time zone, there is a display field which is a text field, and there is date, and there is time format which is the date format. Then you are setting the time zone, the time format which is the date format, setting the time zone, and you are setting the layout which is a grid layout. Then we are saying display is text field, and you are setting the font and so on. Now run. This is the most important thing, because whenever you create an instance of thread, okay, so run method will be executed, right? So what exactly is happening in this? Infinite loop, and it's displaying in the text area. Its text is set to time zone and then time format, right? So I will remove the time zone so that it's easier for us to see. So so you can see this is the time here and this is the time. Both of them are updated concurrently. So you are just getting display, that is the text field dot set text of time format dot format of new date. So you're just formatting this date and just displaying it into the text field. And then you're writing on the console thread.current thread.getName. So it's just getting the name of that thread. It's trying to sleep for 1 millisecond, right? And then interrupted, if the thread is interrupted when sleeping, it's gonna throw interrupted exception, right? And in multiple clock test, you've just created a J frame, you have set the size of the J frame, you have set the title, set the frame to visible, and you've got the time zone for Europe and for Canada, and then you have set the clock instances, and you have the executor, and you use the patched pool, and you started execution of the clock 1 and clock 2, and then you set the layout, grid layout for the frame, added the clock 1, added the clock 2, and frame.pack, which actually causes the window to be sized to fit the preferred size and layout of its subcomponent. And then thread executor.shutdown. So this is the very important example wherein multi-threading is used. So two clocks are updated at the same time, at the same moment, right? So it's trying to share this processor time, and it's trying to run whenever it's free for 1 millisecond. It's trying to update the second clock. Okay, so you can see which thread is executed. So pool 1 thread 1, pool 2 thread 2, whichever thread is executed, you can see the name of that thread here. Okay, so there's just one pool that is created, and there are 2 threads. So there is thread 1 and thread 2, which is, updated one after the other. You'll see it's so fast, it's updated in a fraction of millisecond that we are even not able to identify that they are not updated at the same time. Yes?
If you change the sleep time, would it take longer?
If we change the sleep time, that's a very good thing. So if we go here, you want to change it, that means you want to make it less.
Like slower, like would it make it slower? Would it make it
Slower, that means you want to extend the sleep time, or you want to
Yeah, like
extend it?
Yeah.
Okay, so if I make it 10 milliseconds, then what happens?
You're gonna update time each 10 minutes.
Sorry?
You're gonna update time each every 10,000.
Yeah,
So it's
every
not gonna be
10
very
milliseconds it's gonna be updating this.
But time is gonna be right, or you're gonna, oh yes, right.
Oh, so we just
Time is gonna be right, but it's gonna be updating after the sleep cycle is done. Right? So the thread is sleeping, so it cannot do anything else, right? So when it wakes up, only then it will update the time. So 1 millisecond it was sleeping, so it was updating as if it's the real time. Right? But if it's 10 milliseconds, so it doesn't look like it is real time, right?
No, I mean, you're gonna update like each 10,000, time will be correct.
Yeah, time is gonna be correct because it's doing the task, but the time it's sleeping, it's not updating the GUI, so it looks like it's not updating.
But I guess if you don't wait in like milliseconds, just hours and minutes, it's gonna be enough. Because you're gonna update maybe every
Okay, that's a good question. Suppose if we try to not let it sleep, then what?
That probably
Okay, you want to try this?
Yeah.
Not letting it sleep?
crash. Oh, it doesn't.
very quick.
So it's just a regular 1 second. By default, I guess.
Yeah, so it's not sleeping for 1 millisecond, so you can see how fast it's executing these threads. We are not even able to see or look at how it's updating. It's updating so fast. Right? But it's just to show that if it's performing something in background or some other thread is executed at the same time, still it's doing the work in real time. It's so fast.
I guess it just hold the processor.
It's going to overload the processor. Yeah, it's trying to execute infinitely these 2 thread pools. But your processor is smart enough, it just has this much more time. Even though it's working on this time updating, it still can do something in background that is taking 1 millisecond. Yeah? So you can add more threads, yeah, that means, yeah? This is about an application of multi-threading. Everyone's good so far? Okay. Now let's talk about the details. The thing that I was talking about, that is one array, and you are trying to coordinate access to shared data. So we were talking about the thread T1 and T2, right? This thread T1 was trying to make this array's element as 6. Second thread T2 is trying to make it as 4, right? So it's saying that if you are having a shared data, so both the threads are using the same data, right? So in this case, the results are indeterminate. We don't know what the result would be. right? So the best option that is used is for exclusive access. So this T1 gets exclusive access to this array. Once T1 gets exclusive access, T1 is going to write 6 here. Okay? Then T1 is going to leave that exclusive access. It's going to leave it. Then that exclusive access will be available for T2. And then T2 will get the exclusive access and update the array again. Right? So this is what happens in thread synchronization. That is, it's gonna give exclusive access to the thread, and only that thread can access the array till that time. Okay, once the access is done, it cannot update the elements of the array, right? So whichever thread needs the access, it's gonna take the exclusive access and it's gonna leave the access whenever it's done. Now this is very good. It seems to solve our problem, but there is again another problem that it creates, which is not important to know, but just for your information I'm showing you. So suppose there is a simple addition I'm showing you guys. So there is simple addition that you are trying to do, and there are two threads that are performing this addition. Okay, so thread T1 has lock A, has an access to A, and it's waiting for B. It's saying if I get B, I can add these two numbers. But same is true for T1. T1 also wants to, T2 also wants to perform the addition. It has the exclusive access for B, and it is waiting for access to A. So it's waiting for access to A. Now it has one of the access, but it is waiting for another. This one also has access to one, and it's waiting for another. So both cannot run or execute because it's waiting for some resource. So this condition is called deadlock. Okay, so it's trying to access, but it cannot get access. So this is a situation. So Java has a solution. Java has built-in monitors. So built-in monitors are gonna check that object is completely locked. So if there is an object that has A and B, so both of the objects are locked. So in that case, one thread is gonna have access to this object. Obviously, if there are two objects, then again the deadlock is gonna be there. But there is a monitor lock which Java has, which is gonna monitor and make sure that just one thread has the token. It is as if you have the token with the success advisor. So if you want to talk to the success advisor, so you're gonna have a token, and once you have the token, only then you can go to the appointment, right? So lock has a token. Lock means it's a token that the thread will have, and if it has that token, only then it can access the variable or access the object, right? So how do we get that access or lock? So first you can ask the Java monitor to make sure that whatever object it needs, that needs to be locked. And how is that possible? So as a programmer, you are going to use synchronized method or synchronized statement. Okay, so you are going to create your method and specify that this method is synchronized. So it's the job of Java's monitor to make sure that that object is not acquired by anyone else, right? And if something is within the synchronized statement and some other thread is executing that array, so if this array was accessed within the synchronized block and T1 had an access to this, so T2 will not run unless T1 completes the execution. So this is the importance of synchronized block. So synchronized block or synchronized object and the statements within it. So this enforces mutual exclusion on a block of code. So where the object is object whose monitor lock will be acquired, normally this. This is also one of the way using which you can use synchronize statement. You can create a method within it, synchronize this and whatever you want to do. Another way is here. You see the program related to it. So first we'll see this one. No, we'll see the first good one, good program, then we'll go to the bad one. So this is an array writer, okay, which implements runnable. So that means this is a thread, right? So whatever is inside run, that's gonna happen. It's gonna run that. So what exactly it's doing here? For from the starting value to 3 more locations, it's gonna add the elements to the simple array, simple shared array. So this is the simple shared array. It's gonna add elements from the starting value to starting value plus 3. It's just gonna add these values to the simple shared array, right? Now what exactly it's doing here in simple array? Simple array, it's performing add, and add what it is doing is it's writing the position equals right index. So it knows that it has to write from this position, and the sleep thread is going for sleep, yeah, and array position equals value. So this is very important. In real application you shouldn't sleep while holding a lock, right? This is just to show that, you know, if there are more statements or if it takes more time, then what is going to happen to the state of the thread. So it's just to add that one. Now you are just placing the appropriate value. So whatever value is passed here, that is placed into the array's position. And you are saying that thread name wrote some value to element at this position, and you incremented the index. And you said next write will be at this index, right? And you said to string, it's just displaying the string. There is just add that we are calling. And in the shared test, you have created 2 threads, and you're passing 1, which is the start value. So it should actually, if it was not concurrent programming, what it should do is it should create a simple array of size 6. I'm just going to show this, what exactly it should do. So what it should do is, it should create an array of size 6. Correct? So it should create an array, which is a shared array. And then writer 1 should start from 1. And it should add all the elements, 3 elements into the array. So 1, 2 and 3. Then writer 2 should start from 11. So 11, 12 and 13. So these 3 values should be written in the array. So that's what should happen ideally if it was a normal program. So if we are using this synchronized program, then the output is 1, 2, 3 and 11, 12 and 13. That's what we want. But this is possible only after you make your programs make your methods synchronized, wherein no one else can access our array unless the method is completed execution. But if it was not synchronized, like in this case, wherein sharing without threads, so it's again creating the threads and it's trying to run this program. So you run this program, you see that pool 1, thread 1 wrote 1 to element 0. So 1 was written to element 0. Then what it did, next write index is 1. Now thread 2 came in and it wrote 11 to element 0. So instead of 1, now it wrote 11. So 1 was overwritten and now this became 11. Right? Because the thread that is writing last, that value will be stored at that index. Right? Because both are trying to manipulate at the same time to the array. Both are using the shared array. Pool 1, thread 2 wrote 11 to element 0. The next write index is 2. So pool 1, thread 2 wrote 12 to element 12 to element 2. Right? 0, 1, 2. Correct? And next write index is 3. Next write index is 3. So it wrote 2 to element 1. Again, this is remote. No, it's element 1, right? So it wrote what? 2 to element 1. And next write index is 4. So thread 2 wrote 13 to element 3. Now next write index is 5. So it wrote, thread 1 wrote 3 to element 4. Next write index is 6. So it did not write anything, so it's 0. By default, nothing is there, so it's 0. So it is 11, 2, 12, 13, 3 and 0. But ideally we were expecting 1, 2, 3, 11, 12, 13. But because any thread is trying to access this shared array, so the array state is unusual. We don't know what exactly is written there. So this is similar to the example that we were talking about. So both the threads are trying to write at the same time here. So sometimes the output might be 6, sometimes the output might be 4. We don't know. So we make the method as synchronized so that this thread is going to lock this array and it's not going to allow update unless the second thread, unless the synchronized statement execution is not done. Till that time the lock will not be released. Okay? So just make the method as synchronized. Same code, just the methods need to be synchronized. So the simple array methods are all just written with the keyword synchronized, and it's going to make sure that once the thread T1 is executing, so it's not going to allow any other thread to execute that. So you can see thread 1 wrote to element 0, next index is 1. So thread 2 wrote 11 to element 0. So this is again wrong. So you can see thread 1 first wrote to 1 index, 1 to index 0. Thread 1 again wrote because it's synchronized, so thread 1 has the synchronized access. Then thread 1 again wrote. Once it is done, only then the thread 2 got the access to element. Then thread 3 got. Then thread 3 got. So is it good to use synchronized? Is it good?
Yeah.
Yeah, why do you think so?
So we can manage time for the threads. So
11. So if you are using synchronized, so it's not gonna go into indefinite state. It's state that we won't be able to predict, right? If you are using synchronized, it's gonna make sure that the thread that is current thread which is holding the current object will keep the object locked till the time its execution is not complete. So once the execution is completed, only then it's gonna release the lock. Okay?
Is the value any random value, or is the value that you just put in yourself?
Sorry? Here?
The parameter.
Integer value.
This one?
Line 21.
No, the parameter for the actual method. Yeah.
Value? This is the value you are adding to the array, to the shared array actually.
Where's the array?
So this is the array.
Or the constructor.
This is the common array that you are sharing. You are initializing the size inside the constructor, and you initialize the size as here. In test, you initialize the size as 6, and you said that in the run method, in the run method,
It's a run.
where is the run method? So array writer. So in the run method, you are just adding this I into this shared array. So you are trying to go from the start value, which is given here. Okay, where is that? So you are saying start from 1, right? And you are saying till 1 plus 3, that means 4, less than 3, less than 4. So 1 to 3, that means 1 to 3, it's gonna add these values into shared simple array. Correct? Is everyone with me? And then we are saying start from 11 then. 11, 12 and 13. Add them next to the shared array. So add them to the shared array. From starting values 11 to 11 plus 3. That means 11 to 13. Add them to shared array. So you are trying to access the shared array. This is simple shared array, which is of type simple array, which is here. So you are trying to add at position, which is the right index, which is starting from 0, and then you're gonna say thread.sleep, sleep for some time, and then you're saying array of position equals value, and you're just adding the right index plus plus, and then you're saying that this thread wrote this value to this position. Is that clear? And this toString is again synchronized so that the thread has complete access to the array. So the array that you are trying to access is locked by thread T1. So till the time it's adding more elements, it's not gonna release the lock. Okay? So till the time T1 is accessing this array, it's not gonna release the lock. Once this task is done, it added 6 here, only then lock will be released, and then it will be permitted, T2 will be permitted to acquire the lock on this array. And then T2 will update the array. Is it clear? Any questions?
The synchronize, is that a user-defined method?
Which method?
The synchronize? Is that
Synchronize, that's a keyword which is Java keyword.
Okay.
Okay?
So we have to implement the code ourselves?
So the code, if suppose this is the code,
Yeah.
if this is the method and you want, this method to share a common array which should not be in indeterminate state, so you make this method as synchronized. So when you are doing your programming, you are creating your method, you want the data to be shared among threads, just make sure you are creating that method as synchronized. Okay, so that any thread which is trying to update that value will not be able to acquire the lock unless someone else is working on the same array. Now there is another API or another class which is used for same task. It's gonna synchronize reading and writing amongst shared array. That class is called array blocking queue. Okay, so the another example which we have for the week is based on that. Okay, so there is a buffer interface you have created, there is a blocking put, there is a blocking get. Now there is a consumer and producer. So what is consumer and what is producer? Producer is gonna write in the array and consumer is gonna read the array. So just now we were thinking about if both the threads are trying to write at the same place, right? But here in this model, if there is an array of say 1, 2, 3 and thread T1 is trying to write 6, thread T2 is trying to read this location. Okay, what will it read? Will it read 6? Will it read the existing value 2? Again, this is a problem, right? So what should happen is once the producer writes the value, okay, if the value is written, only then you should be able to read the value. Once the producer writes, only then the consumer should be able to read. Okay, so whenever there is a shared buffer you are using, so in the shared buffer, what you will do is, there is fixed number of blocks. So if you say one block, so there is one block between the producer and consumer. So producer will be able to write on this one block and consumer will be able to read this one block. Now there is a synchronous behavior that should happen. Suppose first time the consumer is just reading, there is nothing inside the buffer. Will this work? Will this work? There is nothing and still consumer is trying to read. No, garbage value is reading, no use, right? So it should wait, consumer should wait till the time producer writes here something. So suppose producer wrote 20. Now there is something for the consumer to read, right? So now once the value is there, consumer is going to read that value and it's going to remove this value from the buffer. Okay? Once the value is removed, the buffer is empty, so the producer knows that now I have to write onto the buffer. Since the buffer is empty, so producer is going to write the new value. Now the consumer is going to check, is the value there? Yes, now it's going to read. So this kind of synchronization between producer and consumer needs to be implemented. And this is done in this example. There is a producer class which implements runnable because it's a thread, right? And there is a consumer class which implements runnable because this is also a thread. Now what we are doing in producer is, we are trying to write the values. Okay? So we are trying to use the blocking put, which is actually this is the blocking put. What exactly we are doing here? We are taking a Boolean value which is occupied and we are saying that, this is just for our information, saying that producer is trying to write but the buffer is full. Producer waits. So it's trying to write 23. Suppose if it wrote 23. Now its second time came to write 25. But the consumer did not read this value. trying to overwrite. Correct? So it understands that buffer is already full. I don't have any spot to write. So let me wait. So it's going to wait state. Okay? So it's just calling the method wait and it's waiting. Right? Then buffer equals value. So we are trying to put. So if occupied is not true, while occupied is not true, that time it's gonna write onto the buffer the value. So if occupied is not true, if occupied is true, it is gonna wait, right? If occupied was true, it's waiting. The producer is waiting. If occupied is not true, so it's gonna write the value onto the buffer. So buffer equals value. Okay? And it's gonna make occupied equals true. Now it sees that occupied equals true, then it's gonna notify all. Notify all saying all the threads that are waiting to access this array, notifying all of them that you can now access this object. Okay? So everyone who's waiting can access this object. Now consumer, what we are doing in consumer, we are calling blocking get. So in the consumer we are calling blocking get. What this blocking get is doing is while not occupied. If this is not occupied, so this is suppose not occupied, that means it's blank. So consumer is gonna wait. Okay? If this is occupied, then it's gonna make occupied equals false and it's gonna read the data. Consumer reads this buffer. And once the buffer is read, it's gonna notify all that whoever wants that access to shared buffer can access that shared buffer. Okay, so this is how you have to implement synchronized buffer when using threads, multiple threads. Okay? Any questions? Any doubts?
You don't mind if you just repeat how the occupied is doing?
Okay. So occupied is initially by default false. Okay? And once the producer is putting something into the buffer, occupied becomes true. And once the consumer is reading the value, occupied becomes false.
So how the in the while loop?
We are checking
No, on the
here. We are checking while occupied is true. That means buffer is already full. Then please wait. Producer, please wait.
Because
Don't try to write.
The first time the occupied is false.
Occupied is false first time.
Yeah.
Yes, so if while this is false, while this is true, only then this is gonna go inside, right? But if it is false, then it's gonna directly go here and it's gonna write onto buffer. Correct? Clear? So yeah, I'm just going